Hey y'all, so this is our very last video and lesson on differential equations. Today we're going to be talking about differential equation slope fields. So the first thing we're going to do to start is define a slope field. So in your notebooks, you should be taking some notes. What is a slope field? A slope field is a sketch of the slopes of your differential equation. A sketch of the slopes of your differential equation at specific points. Specific points on a graph. Okay, why would we need a slope field? And by the way, sorry, specific points on a graph. We're gonna have an example that's gonna make this definition make a lot more sense. But first, let's talk about why would you need a slope field. So, sometimes you'll be given a differential equation that's not separable. So before we had separable differential equations, and we would try to find the particular solution by doing our steps. We would separate, integrate, all those steps that we've been practicing the last couple days. But sometimes you're given a diffie that you can't separate. You actually can't separate the x and the y, and you're asked about the particular solution. So similar type of question, but we can't do this separation integration trick. So another option is to sketch the slopes that you find when you plug in points into the differential equation, and then sketch the solution curve that passes through those slopes to get an understanding about what the particular solution would look like at a specific point. So this might not make any sense yet, but when we go into this example and have a visual, I think that it'll make a lot more sense. So let's go ahead and jump into our example. Oh, and y'all, before we go into the example, I would, if you have a printer at home, I would pause the video and print the lesson. These pages are linked in your OneNote, so you can open it from your OneNote, the Word document, and then print this Word document. Today's lesson specifically has a lot of graphing essentially, and you're gonna want to have the graphs on paper probably. If you don't have a printer and you can't print this packet, what it's like a 4-page packet, 5-page packet. What I would do is use the snipping tool, and I'll explain in a second. But I would use the snipping tool to get some practice, and you could use your finger to draw on the snip of the graph that you take on your computer. Okay, so print the packet if you can. If you can't, don't stress. All right, let's jump into the first topic of this lesson, which is sketching the slope field for a differential equation at a given point. So, on the AP exam, they often ask you to sketch the slope field for a given differential equation at a number of indicated points. So here's an example of kind of what that looks like on the AP exam. Don't mind this stuff for now. So pretend this doesn't exist. I'll cover it up real quick so you're not distracted. Let's read what you would have given to you before you do any work. So on the AP exam, it might have a question that says, sketch the slope field for the differential equation dy dx equals x minus y. And this is not a separable diffie q. So we actually, is this dx? Yes, it is separable. Why did I have that on there? Okay, let's forget that, cross that out. This is separable, but it doesn't matter that it's separable. We can move this y over, right? And then we can move the dx over. That's what separable means. But it doesn't matter because this question's still asking you to sketch the slope field. Okay, so we need to sketch the slope field. Let's talk about what that really means. That means we need to sketch the slopes. Well, what is the slope? Where do we get the slopes from? This is the slope. This is the slope at any point x comma y, right? Like we could plug in a point, x and y, and we would get dy dx. That would be the slope. So we need to sketch individual slopes for each point that the AP exam indicates or asks us about. Well, this has a lot of points, like a lot of points, right? We don't want to sketch the slopes for all of these points. So what we're going to do is we're actually going to sketch the slopes in a specific part of this graph. So we're going to focus on this little square, -2 to 2. I'm going to like do a little square here. You do not have to do this if you don't want to. You can if you want though. We're just going to focus on this little square, and then I'm going to show you the slope field for the entire thing in a second. Okay, so how do we do this? This thing is a table that I'm going to use to sketch these slopes. It looks huge, but I promise it'll go fast. So what I want you to do is, if like on either in your notebook or if you printed the packet, I need you to draw this table. It's like a normal table. We have x going from -2 to 2, right? X goes -2 to 2, but then we need slopes at every point of y equals 2. So that's why y equals -2. That's down here. We need to find the slopes at all 5 of these points. 1, 2, 3, 4, 5. Y is -2 the whole time. X goes -2 to 2. So that's like what this is showing. This is a point. -2, -2. That's this point. So what would the slope be at that point? This is another point. -1, -2. -1, -2. We're going to find the slope at that point. So pause your video. Make this table really quick. Okay, so hopefully you have this table on your paper. You're supposed to have it, and you're supposed to follow along in your notebook, because we need to be able to know how to actually sketch slope fields. So here's the thing. You have x, y, that's your point, and now you have your equation dy dx. That's what we really care about. We care about the slope. That's what we care about on this graph. We're trying to sketch only slopes. So let's find the slope for these points. -2, 2. That means x is -2, so I'm going to plug in, we could say dy dx equals -2 for x, and then negative minus -2 for y equals -2 minus -2 is the same as -2 plus 2. That equals 0. So the slope at -2 is 0. So here's how we're going to sketch the slope field, because that's what we're being asked to do, right? This is my slope at the point -2, -2. Here's the point. My slope is 0. We're going to sketch a dash. So sketch a dash for each slope. You don't want to sketch like a whole line. We're just going to sketch a dash with a slope of 0. So go to our point, -2, -2. And we're going to sketch a dash that has a slope of 0. That's it. We got the dash. Okay, cool. Now let's go to our next point, -1, -2. I'm not going to write dy dx every time, so let's just go ahead and write -1 minus -2 equals, we get -1 plus 2, which is +1. So at, actually, you know what, I'll just do all of this in purple. At the point -1, -2, -1, -2, we need a slope of 1. So I'm going to I like to use these points to let me know the angle of my dash. This is over 1, up 1, right? That's a slope of 1. That's how my dash should look. That's a slope of 1 at the point -1, -2. Okay, let's do 0, -2. So x is 0 minus y is still -2 for my point. We have +2, right? That's my slope. I need to go to 0, -2, and do a slope of over 1, +2, up 2. So my dash needs to be in line with pointing, it needs to be pointing at this. That is a slope of +2. It should look a little steeper than this one, right? Slope of 2, slope of 1. A little bit steeper. Okay, let's keep going. 1, negative 2. So we have 1 minus negative 2 equals, that's 3. Slope of 3. So it should be even steeper. Over 1, up 1, 2, 3. It should be pointing at this guy. Slope of 3. All right, and then our last one, 2 minus negative 2. I bet you could guess what it is, 4. So slope of 4 is going to be even steeper over 1, 1, 2, 3, 4. It's going to be pointing at this line, slope of 4. Okay, on AP exam, they're not going to be super crazy about you getting the slopes perfect. They want to see like approximately the correct angle. You should be able to draw the correct angle for these little dashes. Okay, so now that we have the hang of this, I'm going to do this little red section. Then I'm going to pause and let you fill out the rest of it. And then you can check that you correctly did it. So let's do this red section. X is negative 2, negative 2. Y is negative 1, minus negative 1 equals. That's negative 2 plus 1, which is negative 1. So at the point negative 2, negative 1, negative 2, negative 1, I need a slope of negative 1. Remember, that's going down, and it should be pointing at the point directly diagonal. There's my dash. Okay, x is negative 1 minus y is negative 1 equals negative 1 plus 1, 0 again. So negative 1, slope is 0. X is 0 minus y is negative 1 equals positive 1. So at the point 0, negative 1, I need a slope of positive 1. That should be the same angle as this slope, right? Positive 1, positive 1. So see what I mean by like you have to focus on the angles? All right, let's keep going. We have 1 minus negative 1 equals 2. If you want, you can like fill these out first. Minus, 2 minus negative 1 equals 3. So at 1, negative 1, I need a slope of 2. 1, negative 1, I need a slope of 2. And then at 2, negative 1, 2, negative 1, I need a slope of 3. So over 1, 1, 2, 3, I'm pointing up at that guy. It's getting steeper kind of as it goes. Okay, see how I'm doing dashes? I'm not connecting them. Each point that we find the slope at is like a separate slope. So you need a separate dash for each point that you find the slope at. Okay, so what I want you to do is pause your video, try to fill out the rest of these, and then you'll be able to check yourself. I'm going to have it like skip ahead so that you can see all of mine filled out. Okay, so now I'm going to fill out all of mine. So we have negative 2 minus 0 equals negative 1 minus 0, 0 minus 0, 1 minus 0, 2 minus 0, and nothing's changing because we're subtracting 0. So we have negative 2, negative 1, 0, 1, and 2. So at negative 2, 0, negative 2, 0, I need a slope of negative 2. At negative 1, 0, I need a slope of negative 1. At 0, 0, I need a slope of 0. At 1, 0, I need a slope of 1. And at 2, 0, I need a slope of 2. Boom, got my dashes. Now we have negative 2 minus 1, negative 1 minus 1, 0 minus 1, 1 minus 1, and 2 minus 1. Oops, equals negative 2, that's negative 1, equals negative 2, equals negative 1. Oops, this is negative 3. Sorry. Negative 1 equals 0 equals 1. So at negative 2, 1, I have a slope of negative 3. So that's going to go over 1, down 1, 2, 3. That's going to be pointing at this guy. Steeper. Okay. At negative 1, 1, negative 1, 1, I have a slope of negative 2. So it's going to be pointing at this guy. And then at 0, 1, I have a slope of negative 1. So 0, 1, slope of -1. See how they're getting less steep? At 1, 1, slope of 0. And at 2, 1, I have a slope of 1. As you can see, this has a pattern. If you haven't noticed already, all the diagonals line up. These all have a slope of 1. That's not always true. It's because of the differential equation that we have. All of these have a slope of 2. All of these have a slope of 3. All of these have a slope of 0. They're like following a pattern diagonally. Oops, I accidentally added a little dash. So following that pattern, I don't have to really fill this out. I know that this is going to have, so this is going to have a slope of 0 because it's going to follow this diagonal. This is going to have a slope of -1 because it's going to follow that diagonal. This is going to have a slope of -2, -3, and -4. Cool. So we have finished practicing drawing the slope field dashes. This is a really cool tool that I want y'all to know about. So you can find this link in your OneNote. Let me just like scroll up a little bit or down, whatever. Okay, so this slope field calculator by Desmos, the link is in your OneNote. It can show you this entire slope field. All you do is type in the differential equation that you start with, and it'll show you the dashes that like on any size slope field. So you could zoom out and it'll have all the little dashes for each slope at each point. So I want you to like check yourself when you're doing slope fields by using this calculator, and it's just check it out because it's a super cool calculator. Okay, so now that we know how to sketch the slope fields, I actually have finished this sketch down here for this function that we were working with, and we're going to talk about how to sketch the particular solution on a slope field at a given point. Okay, so before we were just sketching the slope fields, just the slopes. So that's like here, we have this slope field. It's just a bunch of dashes that represent slopes at each point, that represent the differential equation at each point. Now, sometimes on the AP exam, they'll ask you to sketch the particular solution to a differential equation on a provided slope field at a specific point. So, for example, well, actually, let's get to the example later. Let's go through first, how do you do this? So, we're going to follow these steps. When you're sketching a solution curve or a particular solution, you're going to put the point being asked about on your graph. Make sure that you actually label the point on that graph. They gave you a point, put it on there. That should be free, like a freebie. And then 2, sketch a curve that goes with the flow. So like goes with the flow of the slope field dashes. So this is our flow. And then make sure that your curve goes through the point that you actually were given and the point that you put on your graph. When I do this, I like to pretend that my point is a plastic bag and it's drifting through the wind, and the slope field dashes represent the wind. So like these are kind of like little dashes that are representing how the wind is moving. Our point is going to be, thanks to Katy Perry, we're going to call our point a plastic bag, and we're going to draw or sketch where the path that the plastic bag would take on the wind or on the slope field. Okay, so let's do this. Sketch the solution curve. This is what it would look like on the AP exam. Sketch the solution curve to dy dx equals x minus y. That's the diffie-q, the differential equation that we were just working with. At the point 1, 1. Okay, first of all, they gave us a point. Go to your graph and put that point on your graph. So 1, 1, gonna put a point there. And sketch the solution curve at the point 2, -2. All right, so we have the point 2, and then -2, put that point on my graph. Cool. Okay, so now we do these steps. First step, put the point on the graph. Second step, sketch a curve that goes with the flow. So pretend that these points are a plastic bag. These are going to be the solution curves, the particular solutions. It's going to be kind of like these. Let's sketch them first and we'll talk about what they mean. Sorry. Okay, so plastic bag. This is the wind. I'm going to start with this plastic bag. We have two separate plastic bags. This one, if it goes to the right, like in this direction, it's going to kind of go up with the wind and then kind of like level out right here because this wind is going to like stop it. So it's going to go maybe like this, right? That wind is going to kind of like keep it down and push it. And then going to the left, the plastic bag is just going to like get steeper that way. Okay, so this is the solution curve to the differential equation. That represents a particular solution to this differential equation at the point 2, -2. So we don't know like what this equation is, but we can tell you approximately kind of what it looks like by using the slope, or by using the slope field that we sketched. Okay, now let's do the second point, or the second plastic bag. So we're here. Let's go to the left first. We know as it goes to the left, the wind is going to kind of send it up, and it's getting steeper. So the wind is going to send it up like that, really steep. And then to the right is a little bit awkward because it like levels out here. So I think I would like draw a little flat thing and maybe like go like that. I don't know if I would like continue it to the right anymore. I might just leave it like that. Okay, and that's sketching a solution curve. Sketching the solution curve to the differential equation on a slope field that was provided. So the AP exam will, sometimes they'll give you the whole slope field. Sometimes they'll ask you to sketch the slope field and sketch the solution curve. No matter what, they're never going to ask you to sketch this many points. So let's like go to an example now of the number of points, that has the number of points that an AP exam would ask about. And actually, this will be your practice problem. So what I want you to do now is practice this problem. If you're on YouTube, then pause. You are going to, on the axis provided, that's this, sketch a slope field for the differential equation dy dx equals x minus 1 over y at the 12 points indicated for -1 to 1. Sketch the solution curve that passes through the point. Okay, so you're doing two things. You're going to, one, sketch the slope field. So that's what we had in blue on the last example. And then 2, you're going to actually sketch the solution curve. That's the line. If you're imagining the plastic bag is the point 0, -1. So no matter what, you could put a point right there, right now. Okay, so practice this problem and see if you check your answer, see if you did it right by looking at the video once you're done. All right. So how would we do this problem? This is kind of a pain in the butt. This one actually asks you to sketch it at more points than normal, 12 points indicated. That's a lot of points. Sometimes it'll just be like at 5 points. That's a lot nicer. So the first thing we're going to do is do our like XY table thing that has X, Y, and it has the diffy Q. Dy dx is, I'm going to say dy dx equals x minus 1 over y. Okay, and then we have to put all of these points in our xy. So the first point would be -1, 2. I'm going to make sure I get all of them. So -1, 2. And then we have -1, 1. We have -1, -1. We have -1, -2. Isn't this so much fun? We have 0, 2. The good news is this isn't actually like really hard, right? It just kind of is time consuming. 0, 1, 0, -1, and 0, -2. And one more set. We have 1, 2. We have 1, 1, 0, or 1, -1, and 1, -2. Okay, those are all the points that they have marked, right? We have to sketch the slope field, sketch a slope field for all of those points. So let's find the slopes at all of those points and then put little dashes to represent each one of those slopes. So we have x minus 1 over y. So we'll have -1 minus 1 over 2 equals, that's -2 over 2, -1. So our first slope is -1, and it's happening at -1, 2. So let's go to -1, 2, and draw a slope of -1. Just a dash. Cool. This is like a legitimate old AP exam problem, so you might have to do this, and you will just draw the dashes exactly how we're doing. All right, so now let's continue to find each slope. I'm going to kind of go fast because you were supposed to try this on your own. So we have -1. I'll just do a couple more examples. -1 minus 1 over 2. Wait, what's y? Sorry, I'm getting all confused. Okay, so y was 1 for this one. So that's -2. So at -1, 1, -1, 1, we want a slope of -2. So that means I'm going to go down 1, or sorry, over 1, down 2. So I'm going to point it that guy. And it should be a little steeper than this. Like, it should look steeper. Okay, so let's do this one. We have -1 minus 1. Y'all, every time the top's going to be -2 if you haven't noticed, or if you didn't notice. -2 over -1 equals 2. Then we have -2 over -2 equals 1. So at -1, -1, we have a slope of 2. You see how I'm using like these dots instead of going over 1, up 1? I'm going over 1, up 2, and then trying to like line my steepness up with the dot that's 2 above for a slope of 2. And then for this one, we have a slope of 1. Okay, and then let's keep going. 0, 2. Well, first of all, let's see. If we have 0 for x, the top is always going to be -1. So I have -1 over whatever my y is, 2. That equals -1/2. And then we have -1 over 1 equals -1. That's for this guy. We have, I'm going to stop doing these. So we have -1 over -1. That's 1. I'm going to try to keep them, or get them back to being aligned. We have -1 over -2. That's 1/2. Okay, so let's do those real quick. Let's draw our slopes. Where were we? Right here. So 0, 2, 0, 2. We should have a slope of -1/2. So rise is -1 over 2. That would be like over here. So we would have this slope pointing over at that guy. That's a slope of -1/2. At 0, 1, we have a slope of -1. 0, 1, slope of -1. At 0, -1, we have a slope of 1. Sorry. And at 0, -2, we have a slope of 1/2. So we're going to go rise over run, right? Up 1, over 2. And then draw our slope field dash pointing at that one. Okay. And guess what? This one is so easy. So they asked us for 12 points. It's a lot because this last chunk should be a lot easier and faster to find. So x is 1 here, right? Anytime x is 1, you have 1 minus 1 on top. So like we have 1 minus 1 over 2. Well, 1 minus 1 is 0. If you have 0 on top, that just turns into 0. That's true for all of these. X is 1, x is 1, x is 1. All the tops are going to be 0. So the slopes for all 4 of these is 0. So we're going to go 0. Oops, that was bad. 0, 0, 0, 0. Okay, now we've finished sketching the slope field. That was this part, sketch the slope field. Now we need to sketch the solution curve that passes through the point that they gave us, 0, -1. So we've already put that on our graph. This one's a little tricky. Oh, and it says sketch it from -1 to 1. So -1 to 1 is like our zone that we need to sketch this this solution curve in. And here's the thing that's tricky about this. We need to actually like figure out what's happening here where y equals 0 and x equals 1. So let's check the slope here. Even though we didn't put it on our graph, we have dy dx equals x minus 1 over y, and we know that this point is 1, 0, 1, 0. Let's check what the slope is. So if we plug in 1 for x, we get 0 over 0. and 0 for y. All right, this is undefined. So there actually isn't a slope here, and there's also not a point here. So, well, what I'm saying is there's not a point on our slope graph. Slope is undefined, so you're going to put a point that means undefined on your graph. So we're going to put an undefined point because we need to sketch the curve from here to here. And then everywhere else we know the slope. This curve is actually just going to stick to here. It's on a plane. It's on like a spot where the wind is just blowing straight this way. It's being very consistent, and it's being pushed. The the like plastic bag is being pushed like to stay on this plane. So that's the solution curve. Boom, done. Okay, that one was kind of complicated. Now I want you to go to the next one. This is also a practice. This is actually easier, though, than the last practice. Let's read it really quick. The slope field for the diffy q dy dx equals 2y minus 4x is provided below. Sketch the solution curve. Sketch the solution curve that passes through the point 0, 1, and the solution curve that passes through the point 0, negative 1. Well, why is this easier? First of all, it gave you the slope field, and sometimes they'll do this on the AP exam, which would be really cool if you got this. But it gives you the slope field, and then it also already puts the points on your graph. So all you have to do now is draw your solution curve. Draw the line that goes with the flow through both of these points. So you're going to have two separate lines, one for this point and one for this point. Okay, practice that. Pause if you're on YouTube, and then check your answers after. All right, I'm very quickly going to answer this. So we have the point 0, 1, and we have to imagine it's a plastic bag. The solution curve is going to stick basically on this plane again because you have wind that is going straight right here, right? So the plastic bag is just chilling, and it might bend a little bit, but like I wouldn't worry about how much it's bending. Oops. And if you think about it, these slopes are pushing it to stay on here, and these slopes are pulling it equally. So really, it's just going to stay on this straight line. Cool. So now this one, if we're looking to the right, the wind is going to take this line and get steeper and push it down more. You don't have to put an arrow. I don't know why I tried that. And then as you go to the left, the wind is taking it and getting it closer and closer to what looks like an asymptote here. So I would just leave it like that. That's your solution curve at 0, negative 1. Cool. And then we're done with that part. Sweet. And now let's go through reading slope fields of differential equations. So this is also a skill that's important for AP exam. Being able to like tell if they gave you a slope field, tell me which equation, or tell the AP graders which equation does the slope field go with, which differential equation. So we have some tips for reading slope fields. We're going to go through these as we actually do this example. So let's get into the example. Making sure that you can see all the tips. Okay, so here's our first example. One of the following slope fields is for the diffy q dy dx equals sine x cubed, and the other is for the diffy q dy dx equals sine y cubed. Match each slope field to its corresponding differential equation. So we need to match these. These are slope fields. So remember, these represent slopes. That's why they're dashes. And they're going to be slope fields that go with these slope equations. These are dy dx, so those are slope equations. So let's go through the hints or the tips up here as we're like trying to figure out which equation goes with which slope field. The first thing you should always try is look for the places where dy dx should equal 0. So what do I mean by that? Let's look at this dy dx. This function, this slope, sine x cubed, should equal 0 if, when does sine equal 0? When x equals 0. And then this one, it's like when there's a 0 in here, right, is when that slope would equal 0. And then for this equation, this should equal 0 if y equals 0, because y is on the inside of sine. because sine of 0 gives me 0, and that would give me a 0 slope. So the first thing we should do is always think about what would make these equal 0. Let's see if we can already like match these slope fields to one of these. So this x cubed, sine of x cubed, the slope will be 0 if x equals 0. X equals 0 is right here. It's this axis. This axis. Which one of these has 0 slopes on it? On the y-axis, that's where x equals 0. This one, look, 0 slopes, 0 slopes, 0, 0, 0, 0, 0, everywhere that x equals 0. So we can actually already finish this problem. We can match it. Sine of x cubed goes here. Sorry, dy dx. The slopes are equal to sine of x cubed. That goes to this guy. And then for this one, it has to be the other, but let's check y. So if y equals 0, that's on the x-axis, we should have 0 slopes. Check it out. We do indeed have 0 slopes where y equals 0. So this equation, dy dx, equals sine of y cubed goes here. Now really quick, let's walk through. So the first tip was look for the places where dy dx equals 0. Let's walk through the other ones very quickly. These ones are similar. Try plugging in y equals 0. So like we can't plug in y equals 0 to this guy, but to this equation we could plug y equals 0 and we get sine of 0, which would give me a slope of 0. So we know the same thing where y equals 0, we should have slopes of 0. So like we did this, but sometimes this thing doesn't work as well. Like it's hard to tell where the slope should be 0. So the next thing I would do is try plugging in y equals 0 and then look for where the slope on the x-axis matches that. And then the other thing I would do is try plugging in x equals 0 and then look at the slopes where x equals 0. So that would be look for the slopes at the y-axis and see does it actually like match with your differential equation. Okay, so for this problem we kind of already did that. Now let's talk about other options. If dy dx is only dependent on this one, dy dx is only dependent on x. So that means it only has x in it. So check it out. This differential equation, it only has x in the equation. So this is dependent on x. Then your slopes should match in the vertical direction. That's up and down. So let's look at the one that we said matches sine x cubed. Do our slopes match in the vertical direction? So like if we were to draw vertical lines, are these slopes matching? Yes, they are. These slopes match in the vertical direction. Okay, and then like alternately, if dy dx is, let's just stick with this. If dy dx is only dependent on y, I kind of wanted to do a different color, sorry, because this is a different situation. Then slopes should match in the horizontal direction. So our second equation, this thing was dependent on y. It has just y. It doesn't have y and x. It doesn't have any x's. It just has y. So our slopes should match in the horizontal direction. So if we draw horizontal lines, do our slopes match? Yes, they all match going this way. So that's another way to eliminate. And then the last thing we could do, the last tip that I have is to pay attention to what would make dy dx positive or negative. So like what would make positive or negative slopes. For this thing, it's a little hard because we have trig functions, so I wouldn't focus on what would make your slope positive or negative, but you'll see in the practice that it actually is helpful. Not the next practice, but the one after that. Okay, so now I want you to practice this on here. So one of the following slope fields is for the differential equation dy dx equals cosine y, or cosine xy, sorry, and the other is for the differential equation dy dx equals sine xy. You need to match each slope field to its corresponding differential equation. So it's exactly what we just did. You are going to match the slope fields to the diff EQs that go with them. All right, so try that on your own. Okay, and now we are going to see if you got it right. So our first tip, if we recall, our first tip, I'm going to go back to this. Our first tip was to look for the places where the slope should be 0. For this, we know that cosine of xy equals 0 if, like, x times y equals 0. If the inside, equals pi or 2 pi. Well, we don't have pi and 2 pi matched, or labeled on our graph. So let's think about what would make this equal 0. This would equal 0, this slope or derivative would equal 0 if x times y equals 0. So if x equals 0, or if y equals 0, we should have a slope of 0. So let's look at our graphs. If x equals 0, that's on the y-axis. And if y equals 0, that's on the x-axis. We should have slopes of 0. This is not 0 slope. These little dashes are like, they look like slopes of 1 on the y-axis. So that can't be right, but look at this. On the y-axis, does our slope equal 0 here? Yes, it does. What about on the x-axis, where y equals 0? Yeah, we don't see any lines. That's because it's sitting on the axis and the slopes are actually 0 there. So we can very quickly say this is the graph of sine of xy, or this is the slope field, sorry. dy dx equals sine of xy, and this is the slope field of dy dx equals cosine of xy. All right, one final practice and then you are done for today. So we have similar type problem. You are going to try to now match these 4 differential equations to one of these graphs. Each equation has its own slope field, and yeah, you should be able to use the tips, the tricks to match them. In case you don't have the tips or didn't take them down as notes, here they are. So now try to match all of those slope fields. Okay, so let's see how you did. And I'm going to walk through how I would do these. So for the first thing, the first tip or trick that we have is figure out when these would equal 0. So this would equal 0 if this differential equation, or this slope equals 0 if y equals 0. If the numerator is 0, right? This equals 0 if x equals 0. Diff EQC equals 0 if y equals 0, numerator equals 0, and then this one equals 0 if x equals 0, numerator equals 0 again. Okay, so that wasn't super helpful, with fully eliminating, but we can label, 2 options on these graphs. So I'm going to do that. So y equals 0, that's my x-axis. My x-axis slope should be 0. So this one definitely doesn't have slopes of 0. This has slopes of 0 for my x-axis. So we know that A is an option for graph 3, or A, or the other one that has slopes of 0 on the x-axis is C. And then we have another graph that has 0 slopes on the x-axis. This has vertical slopes on the x-axis, so that can't be right. But here we also have 0 slopes on the x-axis. So A or C are options for number 2 as well. Okay, and then this slope, we would have 0 slopes, 0 slope dashes, like the horizontal dashes, if x equals 0, so on the y-axis. So here's our y-axis. We do have horizontal dashes, and then same with letter D. So this has to be B or D. And then this graph also has horizontal slopes on the y-axis. So again, B or D is an option for 4. Okay, now let's look at our next tip, or one of our other tips. One of the other tips was pay attention to what would make the slope positive or negative? What would make the slope positive or negative? So I'm going to write a little note. So look, we have y over x and x over y. These will be positive slopes. So positive slopes if both x and y are either both positive, or if they're both negative, if x and y are both negative, then we have a negative over a negative, or a negative over a negative, and that would turn to positive. So we know we should have positive slopes on the graph where x and y are both positive. That would be in quadrant 1, right? So I'm going to write Q1, positive slopes in Q1, and where x and y are both negative. That's quadrant 3. X is negative, y is negative in quadrant 3. Q3. Okay, so we have positive slopes in quadrant 1 and positive slopes in quadrant 3. This graph actually works. Positive slopes in quadrant 1, positive slopes in quadrant 3. This one has negative slopes in quadrant 1, so no. A and B cannot go with this. So we're going to say A or B, and then A or B. And then check it out, y'all. This has to be B or D, or A or B. Well, what happens twice, or what shows up twice? B. So this graph goes with B. And then this graph has to be A or C, or A or B. What shows up twice? A. So 3 goes with A. All right, let's finish it off. What would happen here? We have, for these two equations, because they have a negative in front, we have positive slopes if x and y are both positive, or sorry, negative slopes. Negative slopes if x and y are both positive, or both negative. Because if they're both positive, we still have a negative out in front. If they're both negative, we have a negative out in front. So you still have a negative slope. And so that's still Q1 and Q3. We're looking for negative slopes in quadrant 1. Negative slopes are here, and quadrant 3, negative slopes. So this could be C or D, and then C or D. And then again, we're going to take the one that shows up twice. So this has to be C. And then last, this graph number 4 has to be D. Okay, I know that was a lot, but that's the end of your DiffyQ unit. So here's the thing. Y'all have an opportunity for extra credit and just some like fun. There is a slope field card match game that we were going to play in class, but obviously we can't do that now. So if you want, you can play this against your peers. It's optional. Whoever wants to do this can do it. You have this in your OneNote. You can copy the table, and then you can fill out the table based on your guesses. But basically you're given, if you're not going to play the game, you can end the video now. But basically you're given slope fields, you're given differential equations, and you're given descriptions of the slope fields in this game. And then you have to match the slope field to the differential equation to the description or conclusion about the differential equation. Once you fill out your table, you can email it to me. The first one to email me the correct table wins the game. I will give up to 10 places. So first place through 10th place will get extra credit points. All right, y'all. That's it for today, and that is it for our DiffyQ unit. Please, again, work hard in your mastery check. It's all related to slope fields, and it's important for the AP exam. I can almost guarantee that they're going to have a DiffyQ problem on there. If they don't, I will be shocked. All right. Y'all have a great day. Bye.